The formation of the Earth is believed to have occurred approximately 4.6 billion years ago. The most widely accepted theory is called the nebula hypothesis. According to this theory, the formation of the Earth can be traced back to a giant cloud of gas and dust known as a solar nebula. Here's a step-by-step breakdown of how the Earth was formed. Solar nebula formation. The solar nebula formed from the remnants of a supernova explosion. The cloud of gas and dust was composed mostly of hydrogen and helium, but also contained heavier elements like carbon, nitrogen, and oxygen. Protostar formation. The solar nebula began to collapse under its own gravity, forming a dense, hot core called a protostar at the center. Protoplanet formation. As the protostar continued to shrink, it spun faster and flattened into a disk shape. Dust particles in the disk began to stick together through a process called accretion, forming larger and larger bodies called protoplanets. Planetesimal formation. The protoplanets continued to collide and merge, forming even larger bodies called planetesimals. Terrestrial planet formation. The inner part of the solar system was too hot for gas to condense, so the planetesimals that formed in this region were primarily composed of rocky material. Over time, these rocky planetesimals continued to collide and merge, forming the terrestrial planets, Mercury, Venus, Earth, and Mars. Differentiation. As the Earth grew larger, the heat generated by the collisions caused the planet to melt. Heavier materials like iron sank to the center, while lighter materials rose to the surface, creating distinct layers within the Earth. Atmospheric formation. Early in its history, the Earth's atmosphere was likely composed of hydrogen and helium, but over time it was transformed by volcanic activity and the emergence of life forms. Continents formation. As the Earth cooled, the crust solidified and continents began to form through a process called plate tectonics. This is a general overview of the Earth's formation. However, it's important to note that there are still many unanswered questions about the details of how the Earth was formed, and scientists continue to study this topic in order to gain a better understanding of our planet's origins. The Earth formed around 4.5 billion years ago, along with the rest of the solar system. The prevailing scientific theory for how the Earth formed is known as the accretion theory or nebula hypothesis. According to this theory, the solar system began as a cloud of gas and dust called a solar nebula. The nebula was composed mainly of hydrogen and helium, but also contained heavier elements such as carbon, nitrogen, oxygen, and iron. Over time, gravity caused the cloud to collapse inward, spinning faster and faster as it did so. As the cloud contracted, it began to heat up, eventually reaching temperatures high enough to melt the materials within it. As the cloud continued to collapse, it flattened into a disk, with the sun forming at the center. The remaining material in the disk began to clump together due to gravitational attraction, forming smaller bodies known as planetesimals. These planetesimals collided and merged to form larger bodies called protoplanets. Eventually, the protoplanets grew large enough to become planets, with the Earth forming from the collision and merging of multiple protoplanets. As the Earth cooled, the heavy elements sank to its core, while lighter materials rose to the surface. This process, known as differentiation, created the layers of the Earth we see today: a solid inner core, a liquid outer core, a mantle, and a thin outermost layer called the crust. In summary, the Earth formed from the aggregation of dust and gas in a solar nebula, followed by the accretion of planetesimals and protoplanets. The collision and merging of these bodies eventually led to the formation of the Earth, which differentiated into its current layers over time.